Welcome to physics class on motion in a plane. In the previous video we have learned about the projectile, what is meant by projectile, what are the different types of projectile. Projectile motion can be considered into two independent motions: uniform motion along the horizontal direction and uniform acceleration motion, or rather uniformly accelerated motion in the vertical direction. And we have also learned about that over the finding of the expression of time of flight, range in the case of horizontal projectile. But in today's class we will try to learn about the angular projectile. Angular projectile is that projectile which is thrown or projected with an angle with the horizontal direction. So let's see what we can learn from here. We will try to learn about the finding of the expression of the trajectory of the projectile, then time of flight, then range, then the velocity of the projectile at any instant of time in its trajectory. We need to find it out, all those things. So let's try to learn about the angular projectile. That means projectile fired at an angle with the horizontal direction. Okay, now we will see that this is the motion of the projectile. You will see there, this is the origin, and from here the projectile is fired with some angle alpha here, and the initial velocity with which the projectile is fired is denoted by v naught. You may denote this v naught by u naught also, no doubt. Okay, this is a matter of just notation only. Okay, you can use u naught or v naught, doesn't matter. Okay, so this is along the x-axis. So if you resolve this v naught into two rectangular components, one along the horizontal direction and another along the vertical direction, if you know this angle alpha, then the horizontal component will be what we call it, that as what alpha component, as alpha is having here, so that will be always cosine. So if the velocity is v naught, then the horizontal component, that means along x-axis, will be what v naught cosine of alpha, and the vertical component will be what v naught times of what sine alpha, right? So this is the trajectory of the projectile, and it is what a parabola, right? So let's try to find it out. Now this, what happened, the time taken by the projectile to remain in the air, okay, that we call it the time as time of flight. Okay, and the maximum distance that can covered, okay, by the projectile in the horizontal direction, we call it this distance os as the range or horizontal range. And the maximum height it can attain, okay, the maximum height that projectile can reach, that height we call it as maximum height, and it may be denoted by capital heights also, but here it is written as small heights, but that can be written with what, capital heights. That is a general notation. So we generally use this as also horizontal direction. Okay, the angular projection, that is with the initial velocity. This initial velocity is also denoted by u naught in a general notation, or by simply u. Okay, but here it is just a matter of some explanation or to show you the motion of the projectile. Okay, now let's see in the next slide. Now along x-axis, as I told you, that we can denote it this the velocity of projection as u. In that diagram the angle of projection was denoted by alpha, but here it is denoted by phi. Okay, and the velocity, okay, of projection at the very beginning, or at the very initial stage, at when t is equal to 0, it was here. So at the very initial velocity is denoted by u. So the x component will be what, this is your phi component, because phi is here. So your velocity component along this x-axis or horizontal direction will be what, u cosine of phi, and your vertical component will be u sine of alpha. So this is showing what, the position, okay, of the trajectory at any point, say small t. At that point, what happened? The velocity component along x-axis and that along y-axis is denoted by vx and vy respectively, and this will be the direction of the velocity of the projectile at this point. Okay, so what happened? This velocity will be along the tangent of this trajectory. Okay, trajectory means the parabolic part only. So what happened? Let this velocity makes an angle beta with the x-axis. So by knowing this beta, by knowing this x component of velocity and y component of velocity, we can easily find out the magnitude of this velocity of the projectile at this point or at this time. Okay, and also we can also find the angle of this velocity. That means beta can be also found out. So let's see. Now I told you that in the previous video also, in the case of horizontal projection or projectile, there we can treat the motion of this projectile as the combination of two independent motions, one along x-axis, another along y-axis, right? Along x-axis your velocity is constant. That means all over this, at any point of this, the velocity, okay, in the horizontal direction will be equal to what? U cos theta. It will remain constant. That's why we call it that as uniform motion along the horizontal direction, whereas in the vertical direction it will be what? Uniformly, what not uniformly, rather it should be of constant acceleration. Got it? So now let's see. In the case of this x-axis along, that means motion along the x-axis, we can take it that the component of the initial velocity along x-axis, as I said, it can be denoted by ux. U means initial velocity, x means along x-axis, because this is for along x-axis. But in the case of the discussion of this along y-axis or vertical motion, there will be denoted by uy here. That means what? Initial velocity along the y component. Okay, like that. Now see, this is the what? Horizontal component. That means component of velocity along x-axis, and this is the initial velocity, right? Now let's take it that the component of velocity along x-axis at any time t. That means suppose if you take it that this is at any time t, then what will be the velocity of this vx at this any time small t? Then by using your v is equal to u plus at, the kinematic equation, we can easily find out what will be the velocity. Okay, that means along x-axis at any time, okay, that small t. Got it? That will be equal to, as it is along x-axis, so we will denote it by vx ux plus at, like that. So but here, as I told you, that the motion along the horizontal component is a uniform motion. This u cos theta will be there forever, okay, at its part. That means what happened? Your uniform velocity, suppose if the body reaches somewhere here, then its uniform velocity, this will be always what? Your u cos theta. Okay, and if it is somewhere here also, the velocity will be this one, same. It will be here also same, here also same. Okay, this will be uniform. Okay, that means the horizontal component will be constant. That is what it is seen here also. When you take it that a is equal to at time t also equal to what? Your vx will be equal to what? That is equal to your vx. Okay, this bx will be equal to what? U cos theta. This, that will means it will be equal to this, right? So that shows that your velocity along the horizontal direction remains constant. Got it? So what happened in the next? The displacement. We want to find out the displacement along x-axis at any time t. That means suppose if you are considering this particular time, that t is somewhere here, when it reaches, when the projectile reaches from here to come up to here, then the horizontal displacement means how far it is moving this distance. You can take it here from here also, this distance, as it will be same here. This distance will be denoted by x. Okay, this one x, and we have to use it, that kinematic equation, s is equal to ut plus half at square, like that. So being it is along x-axis, we may take it that this s will be denoted by x, okay, and this u will be denoted by u xt plus half, okay, at square. What is a means this is acceleration along x-axis, and t square like this. But this acceleration in the horizontal motion, acceleration is equal to 0, as it is also here, acceleration is equal to 0, so this second term will not come. Okay, so your what horizontal distance, okay, the displacement at any time t, that will be equal to what, this will be ux, means it will be nothing but it will be u cosine of phi. Got it? So it will be what, your x will be equal to u cosine of phi into t. That is what it is having here. Got it? So it will be in that way only, right? So your from this motion along x-axis, what we can see is that your velocity along x-axis will be remaining constant as u cos theta here, and your displacement will be equal to what, u cos theta into t. Now as it is of uniform motion, your distance and displacement, okay, rather displacement is nothing but it's a vector quantity, so your magnitude of displacement will be equal to the distance in this case, okay, distance from the x-axis, okay, that will be equal to what, s is equal to vt, like that, where v is the uniform velocity. So by applying that also it can be obtained very easily, okay, without going the kinematic equations also, because the motion along the horizontal axis is what, uniform, right? So now let's see about the horizontal motion, okay, that means along x-axis. So component of initial velocity will be what, u sine theta. Got it? And now see for the component of that of velocity vy, that means here like this vy, this vy, we have to use it the kinematic equation, not the same kinematic equation, but here your acceleration is not equal to 0, rather as it is moving upward, okay, if you take it that somewhere here, then the object is moving upward like this, okay, the projectile, rather the body is moving upward, so it is against the gravity, so we need to take it that acceleration is equal to minus g. But if it is falling downward, then we have to take it as plus g. Why we are taking a is equal to minus g? Because the motion, okay, that is upward is against the gravity. Gravity is acting downward like this, but the projectile is moving upward more and more in this direction. So because of that, what happened, acceleration will be what, equal to minus g. And if it is acting vertically downward from here to here, the motion, I mean from this highest peak to the ground, in that case we can take it as acceleration as plus g, but for us it will be minus g, as if we are taking this upward like this, okay. So your vy will be equal to what, your initial velocity along y-axis, that is nothing but u sine theta, okay, and your ay will be nothing but this will be equal to minus g. So after putting all those things, then you will get it as what, your vy will be equal to u sine theta minus g, I'm sorry, so your vy will be equal to what, u sine phi minus gt, okay. And now what about the vertical displacement, okay, that can be also found out here. Suppose if your object is somewhere here like this, at this point your u will be like this, u cos theta, and your vy will be there, okay, which will be given by this relation vy, right? So what is the vertical displacement? Means this distance we call it as vertical displacement, okay, from the origin up to this, okay, that we call it as vertical displacement or displacement along y-axis. So that also same thing, you need to use your kinematic equation, s is equal to what, ut plus half at square. Here we cannot use it that s is equal to vt simply because the velocity along the vertical direction or y-axis is not uniform. Got it? So we need to use it for finding that as what, s is equal to ut plus half at square. So s is equal to ut plus half at square. Here this distance will be along y-axis, initial velocity along y-axis, acceleration along y-axis. So your sy will be denoted by y, this distance, okay, vertical displacement, and your uy will be equal to what? It will be u sine of phi, okay, and your ay will be equal to what? Minus z. So if you put all those things, then it will be coming here as uy is equal to u sine phi into t, okay, minus, from where this minus is coming, but it was plus from minus here because this is equal to what? Minus z. So after putting that, you will get it your what? Displacement along y-axis as what? Y is equal to u sine phi into t minus of half zt square, like this. Now let's try to find out equation of trajectory, and we know that equation of trajectory, it should be always, the trajectory should be always what? A parabola, and for parabola that will represent by the quadratic equation. Okay, so let's see. So at any instant of time small t, we know that x is equal to u cos phi t. We have found out in the motion along x-axis, right? So from there t can be expressed as what? X by u cos of phi. Okay, so your t will be equal to what? X divided by u cos of phi, and also from that vertical displacement y is equal to u sine into t minus half ct squared that we have just done it. Okay, from there, okay, in that relation or into this relation, if you replace this as, if you substitute the value of t from this, okay, that means what happened? Your t can be replaced here or substitute here, then you will get the equation like this. So what is this equation? Now if you try to cancel this u and u here, this u and u, if you cancel it, then it will be what? Like this. So sine phi by cos phi, sine phi by cos phi is what? It is nothing but tangent of phi, right? Tangent of phi, and then it will be x minus, now you see here it is half z x square divided by u square cos square phi. So we can write it that as half z, okay, divided by u square, okay. Instead of this cos square there in the denominator, we can write as sec square phi, okay, and it will be x square like this. So these are all the coefficients of x square. Tangent phi, tan phi is a coefficient of x, and here it is x square, so coefficient of x square is here. So you can take it this as a constant. Why? Because half z initial velocity sec square of that phi, so these are all constant. Okay, so we obtain from this resulting last equation as quadratic in x. The power of x is coming up to be square, so that means this equation is nothing but this is a quadratic equation. So we know that if the equation is a quadratic equation, then what? It will represent a parabola. So what happened? The path of the projectile, what we call as trajectory for a projectile fired with an angle with the horizontal, is a parabola. You can also write like this as I have written. Okay, tangent of phi or x tan phi doesn't matter, it is same. Okay, so your equation of trajectory is what? A parabola. If you are asked to prove it, then you need to prove like this. Okay, now let's see the time of flight. Time of flight, how will you define time of flight? It is a time taken by the projectile to reach or to strike the projectile on a horizontal plane. Okay, that time taken, okay, from its time of projection, at a time of projection to the time when it strikes the horizontal ground, that time taken, we call it that as time of flight. Or rather you can also call it, you can also define time of flight as the time that this projectile remain in air. Okay, that time is also known as what? Time of flight. Okay, this time of flight, we can easily find out the expression from where it can be taken that, okay, the projectile to reach the maximum height, okay, this maximum height And now your motion of the projectile is symmetric. Okay, so the time taken to rise up to its maximum height, we call it that time as time of ascent. Okay, and from that peak value or peak height, maximum height, to come to the ground again, we call it that as time of descent. So as it is symmetric, what happened, time of ascent must be equal to time of descent. So if we take it only that time to reach up to what, this maximum height, as it is symmetric, double of this time of ascent or time of descent will be equal to nothing but that will be the time of flight, capital T. Time of flight is denoted by capital T. So if we are going to consider the motion from here up to that maximum height, then what happened, we need to take it that as what, half of the time period from here to here. If it takes, from here to come to this up to here, if it takes total time capital T, that means time of flight, then to start from here to reach its maximum height, it will take half of it, right? So we need to take the substitution that maximum height will be what, your y will be what, capital H, maximum height. Okay, your y will be taken, suppose if this is the y, and then this y means your vertical displacement. Your vertical displacement will be equal to capital H. Okay, and your time will be taken as t by 2. Got it? So if we use it those things, then what happened, we can easily find out from that kinematic equation, v is equal to u plus at. Okay, so your v means this is considering about the vertical motion, so we need to take it as by uy minus this will be what, plus ay into t. So we will use it this kinematic equation as v is equal to u plus at. So as we are considering about the vertical motion, so we need to take it this as by uy, initial velocity along the y-axis and acceleration along y-axis. So if you put it that y is equal to h, but for this one it is not here, so by is what, when it reaches at this point, what happened, your vertical component of the velocity will be equal to 0. Now what happened, let me draw a little bit about it. Okay, this u cos theta will remain same. Okay, let's take it that of same length here. So this will be all u cos theta. Okay, this line, this line, this line, this line. Okay, this will be of all u cos theta. But for this one, the vertical component b at the very beginning, that means initial velocity along the y-axis, the velocity, okay, what I said is what, the component of velocity along y-axis at the very beginning, this will be the highest, and it will decrease, 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 and it will be 0 here. Okay, there will not be no vertical component. That means at the peak position, okay, at the maximum height, okay, your velocity component, okay, along y-axis, this will be equal to 0. So we need to put it this also 0. But this one, u y sine theta, u y, this will be what, u sine of phi, you need to place it, and ay will be equal to what, minus g. Got it? If you put it all those things here, then what happened, your u y sine theta will be equal to sine phi, u sine phi will be equal to what, your initial velocity along y-axis. If you put it this ay as minus g, then it will be coming up like this. Got it? And you need to put it your t as what, t by small t as capital T by 2, by as I said equal to 0 at the maximum or the maximum height, then what happened, you can do it this as what, see, from here if you try to transfer this, okay, if you transfer this g t divided by 2 on this side, and if you transfer it, okay, that means if you try to express this t, then it will be what, twice u sine theta by g. It is a very simple equation that if you transfer it this, then it will be g, sorry, g t divided by 2, this will be equal to u sine of phi, like this. So if you want to find out this t, then 2 will be going this side, g will be in the denominator like this, so that this will not be there. So your t will be equal to what? Twice u sine phi divided by g. So this is the expression of the time of flight for the projectile fired with an angle with the horizontal. Okay, now let's see about the range of this projectile. Now before going that, let's try to find it out, the maximum height. The maximum height means what? As I told you, that maximum height is here. Okay, maximum height means the highest vertical displacement that can be reached by the projectile. That height is known as what? Maximum height. For that, as I told you, that if you consider from the motion from here to here, that your time will be equal to what? T by 2, right? Your what? Uy will be equal to u sine of theta. Vy at that peak point here, it will be equal to 0. Your a will be taken as, I mean acceleration will be taken as g minus g. This should be also ay. Okay, and your vertical distance, this y will be equal to h. So after putting all those things, okay, in that, s is equal to what? Ut plus half at square. So your x, this s will be sy. Okay, this will be uy, ay, because this is for all the vertical what? Motion. Okay, along y-axis, I mean. So your sy will be equal to what? Maximum height. Okay, or you can use it this instead of this as y also. So you need to replace this y by capital H, that means maximum height. And if you put it those substitutions, then you can easily get it that your h will be equal to what? Like this. Now see here, after putting all those things, y is equal to h here. Now u sine of phi t by 2 here, half g, okay, plus half at square. So instead of a, you need to put it as minus g, okay, t by 2 whole square. Substituting this, okay, the expression of t, whatever we have just done in that time of flight, then if you replace it, that t, okay, t is equal to twice u sine by, what was that? Your expression of time of flight was nothing but this is equal to u sine of what? Twice u sine of phi divided by g, like this. So if you replace it, this expression of t, okay, in this relation, then you will get it as like this. Got it? So after then, what happen if you do some simplification here? It is equal to see u square sine square phi divided by g. Here also u square sine square phi by twice g. So it will be coming up as 1 minus 2. So this will be equal to what? U square sine square phi divided by g. Okay, here, then what happened? It will be 1 minus half. So 1 minus half will be what? Half only. So your expression, the last expression for your maximum height, it will be equal to u square sine square phi divided by twice g. Got it? This will be the last or resulting expression. Let's see. So it will be coming up like this. See, okay, your h will be equal to u square sine square phi divided by twice g. Now let's see about that of the what? Now this is about that of the maximum height. We also call it this as maximum height. That means this height can be maximum. It depends upon what? Your angle of projection. If you keep this okay, velocity, initial velocity constant, then the others are all constant except it depends upon this angle of projection. So at what angle of projection will this height, maximum height, will be maximum again? So we know that sine of an angle, okay, its maximum value is 1. So when we put this 1, okay, then this sine square phi is equal to 1 means sine phi must be equal to 1. So that happens only when phi is equal to what, 90 degree. So when you project, okay, your projectile vertically upward like this, at that time what happened, your maximum, okay, height, that will be equal to u square divided by twice g simply. Now let's see about that of the horizontal range. What is this horizontal range? The horizontal range is nothing but it is the uh, longest distance that can covered by the projectile, or you can also say that it is nothing but this is the horizontal distance from the point of projection up to where the projectile strikes the ground. That distance we call it as what, horizontal range. Got it? This, it is denoted by r. From the point of projection to the point where the projectile strikes the horizontal ground, that distance is known as horizontal range. And we can easily find out this because as the motion is along the horizontal direction is uniform, so we can simply find out by using that s is equal to what, vt. S will be what, your distance, v, okay, t. Why? Because we can use this relation only when this v is uniform. For us it will be what, it will be s x, and v will be also vx, and t will be nothing but that will be your time of flight. Got it? So this sx, the distance along the horizontal direction, this will be replaced by r, that is your horizontal range, and your vx will be nothing, it will be replaced by your u cosine of theta, and your time, this time will be it will be replaced by time of flight, and time of flight we know it that that is twice u sine of theta divided by g. Got it? So if you replace it, then this, okay, your r, okay, will be equal to, this is u into u, that will be u square, okay, and here it is what, twice sine of theta cosine of, not theta, rather it should be phi, I'm sorry, in my diagram I use as phi, okay, so it should be phi, so it should be phi divided by g, is not it? So this twice sine of phi cosine of phi, this can be replaced by what, your what, sine of twice phi. Why? Because your sine of twice phi, this will be equal to sine of, let me write like that, sine of phi plus phi. So if you use it, this expression as that of sine of a plus b, then it will be sine, no, it should be phi, I'm just writing again as theta, sine phi cos phi, again it will be what, another again cos phi sine phi, like that. Got it? So it comes twice, so twice sine of twice phi will be equal to what, twice sine phi cos phi, right? So we can replace it this, okay, relation, okay, here. Got it? So your horizontal range is equal to u square, okay, instead of twice sine phi cos phi, we can write it as sine of twice phi. So your horizontal range will be equal to what, your horizontal range will be equal to what, u square sine of twice phi divided by g. This will be the expression of your horizontal range. So it will be coming up here again. Let's see, it is equal to u square sine of twice phi by g, which is the expression of the horizontal range. Now let's see about that of the condition of the angle of projection when it will have the maximum horizontal range. So maximum horizontal range depends upon this phi. If you think it that this constant u is kept constant, then what happen, it depends upon this angle of projection phi. So this angle of projection phi, it is sine of twice phi. So this sine of twice phi is maximum when this value is equal to 1. So sine of phi is equal to twice 1, it should be like this. So sine of twice phi, the maximum value is at 1, and this will happen when it is sine of 90 degree. So this 90 degree must be equal to this, only then it will give you 1. Okay, so that is twice phi must be equal to what? 90 degree. So your phi must be what? 90 degree divided by 2 means what? 45 degree. So what happened? Your maximum horizontal range will be obtained at what? 45 degree. Got it here? Clear? Yes. So the maximum horizontal range, it will be obtained at 45 degree, and the expression of your horizontal range will be given by this. R is equal to u square sine of twice phi divided by g. Clear? Yes. Now lastly, we will try to find out the magnitude and direction of the velocity at any instant. Okay, that is given here. You can say net velocity of the body at any instant of time. Now let's take it somewhere here the body reaches. Okay, your bx, that is always uniform along horizontal direction, so it will be given by your u cos theta, which was at the very beginning. Got it? But for by, it will be okay changing by the equation like this. By will be equal to uy plus at, but a here it is minus g. Okay, so it will be minus gt like that. Clear? So if you want to find out your magnitude, okay, your magnitude of the vector quantity, then what happen? It will be like this. Here, let's take it in this way so as to make you seen clearly. Let me zoom in like this. So what happened? Your bx, this will be remaining same. Your bx will be equal to u cosine of phi, but for your vy, that will be equal to what? This will be changing depending upon that of the this one minus gt like this. Clear? So if you want to find out this by taking that triangle parallelogram law of vector addition, you can easily find out. But this one, the two components are perpendicular to each other. So what happened? Your v will be equal to square, okay, let me write as vx square plus vy square, and square root of this will give you the magnitude of this v. So I will not go in detail that expression. Rather, your by will be what? This here. By will be this one, and bx will be what? This one. Got it? Yes. Just to find the direction of this velocity at this instant, rather again we can use it this right triangle, and the angle here, let's take it as beta. Okay, so your tangent of beta is equal to what? Perpendicular by what? Base, right? Perpendicular means this is what? By. So by divided by what? This is bx. So if you try to find it out, that beta, then it will be equal to tangent inverse of what? Vy divided by vx. This will give you the direction of the velocity at any instant of time small t. Got it? So that is how you can find it out, the direction and magnitude of the net velocity, and it is also given here the same thing. Got it? Where phi is the angle of the, now here I am using not phi, this should be what? Beta. Okay, this should be what? Not pi, rather it should be beta, where beta is the angle, okay, that the resultant velocity max with the horizontal at any instant. That means here somewhere that beta is here, okay, this angle, right? So with that we come to the end of our today's class. Thank you for watching my video.